Hey guys, it's Miss Adams again, and we are looking at our Algebra 1 midterm review for the 2022-2023 school year. And we're moving on to our Unit 2 material. This is when we were getting into our linear functions, so defining a function and learning how to graph linear functions and evaluate linear functions. So the first thing that it says is to determine which relation is a function. And in order for something to be a function, it can't have repeating x values, and it has to pass the vertical line test. Out of these four options, the only option that is viable is A, because I don't have any repeating x values, so B has repeating x values. If I'm looking at C, C is an example of mapping, so that number 1, which is an x value, or an input, is being used twice, so therefore it cannot be a function. And if I look at option D, if I use that vertical line test, it hits twice, so it does not pass that vertical line test, making A our only viable option for a function. Number 2 says create and then solve the equation. So it says the sum, so sum I know is addition of 2 times a number, and 17 is 15. So I know is going to be an equal sign. 2 times a number, well, I don't know what that number is, so I can say 2x. So now I've got all my pieces that are needed. So I'm going to take that 2x, I'm going to add to it the number 7 is equal to 15. So that is my equation that I've created. Now we just need to solve it. My first step is to subtract 7 on each side, which leads me to 2x equals 8. Then divide by 2. So x is equal to 4. Let's go on to the next page. In our next page, we're going to be graphing and finding the characteristics of the following linear function. So I've given you guys y equals negative 2/3 x minus 4. I'm going to go ahead and identify the y-intercept here because that's where we need to start graphing. So my y-intercept is at 0, negative 4. I also know that my slope is equal to negative 2/3. So I'm starting at negative 4. But then I need to go down 2 into the right 3. Or I can go up 2 into the left 3. Now I just have to connect the dots. Anytime I have a linear function, my domain will always be negative infinity to positive infinity, as will my range, because there's no asymptote limiting how far I can go. There's no min or max here. So my range is also from negative infinity to positive infinity. This is a negative slope, or this function has a negative slope. So this function, it will be a decreasing function, so it will never increase. And it's going to decrease from the values of x from negative infinity to positive infinity. Then if I look at my end behavior, when x approaches positive infinity, that's going to be on the right-hand side of my graph. My y value is approaching negative infinity. And when x approaches negative infinity, so this is the left-hand side of my graph, my y value continues to go up, so it's going to approach positive infinity. This leads us into some arithmetic sequences. So arithmetic sequences align directly with our linear functions. These are going to be sequences that have some sort of pattern of addition or subtraction. And just to remind you guys, the recursive rule is a sub n equals a sub n minus 1 plus d, and the explicit rule is a sub n equals a sub 1 plus n minus 1 times d. So number 4 asks us to write the explicit rule for the following sequences. In order to do so, I need to identify 2 parts. I've got to identify my initial value and my common difference. So the initial value for A is 0. And the common difference for A is going to be negative 3, because each time I'm going down by 3. So now I can say a sub n is equal to 0 plus n minus 1 times negative 3. I'm going to distribute the negative 3 inside my parentheses to get the a sub n equals 0 minus 3n plus 3. And I'm going to simplify by combining the 0 and positive 3 to give a sub n equals negative 3n plus 3. For my second sequence, my initial value is negative 2. And my common difference is 4 because I'm increasing by 4 each time. So I can say that a sub n is equal to my initial value of negative 2 plus n minus 1 times a common difference of 4. I can distribute the 4 inside the parentheses now. So a sub n equals negative 2 plus 4n minus 4. Combine like terms. So this simplifies to a sub n is equal to 4n minus 6. For number 5, it's asking me to write the recursive rule. And usually when you write the recursive rule, you want to go ahead and identify that initial value. So for A, our initial value is 10. For B, our initial value is 0. But now all we have to do is understand what the common difference for these are. So I've got a sub n is equal to that a sub n minus 1 term. In this case, the common difference for for 5a is going to be plus 11 because to get from 10 to 21, you need to add 11. 21 to 32 is add 11, so on and so forth. So that's my recursive rule for 5a. For 5b, I'm actually subtracting by 4 now. So my recursive rule is a sub n equals a sub n minus 1 minus 4. Now let's apply some of these recursive formulas. So I've given you, for A, I've given you the initial value, and then it asked me to write out the first 3 terms of the arithmetic sequence. So I know I'm starting with an a sub 1 value of 5, so that initial value is 5. And my common difference is 2. So 5 plus 2 is 7, and 7 plus 2 is 9. For 6b, I've got a sub 1 is equal to negative 3, so that initial value is negative 3. But now I am subtracting 4 each time. Negative 3 minus 4 is negative 7. And negative 7 minus 4 is negative 11. Now we're going to go away from our arithmetic sequences just for a second, and we're going to be looking at some characteristics from a graph. So it's asked me, what's the slope and the y-intercept of this linear function? So I know I'm actually going to start off with my y-intercept because that's probably the easiest thing to identify. And I've got a y-intercept where x is 0, y is 3, so that's where I actually intercept that y axis. And now from there, I want to look for another point. And I know in order to get to that point, I've got to go up 2 and to the right 1. So that gives me a slope of 2 over 1. In order to write these linear functions, I need y equals mx plus b. So in this case, I've got 3x plus 3. Excuse me, not 3x. 2x plus 3 as my function. Now, this has a positive slope. So this will always be increasing. So it's going to increase from negative infinity to positive infinity, and it will never decrease. This leads us into combining functions and evaluating inputs and outputs given functions. So by far, this is probably the most challenging part of Unit 2 because I feel like most of our students have gotten a little tripped up on when I'm given an input, I've got to solve for an output. But also when I've given an output, I need to find the input. So I've given you these two functions, f of x equals negative 2x plus 4, and g of x is equal to 2x minus 3. And I'm going to use these functions to evaluate problems 14 through 19. So problem 14 says evaluate f at negative 4. So I'm giving you the input of negative 4. So I know that this is going to be equal to negative 2 times the input of negative 4 for my x value plus 4. So negative 2 times negative 4 is 8, leaving us with f of negative 4 is equal to 12. For 15, I'm now going to use my g of x function, and it's giving us the input of 0 for x. So I can say 2 times 0 minus 3. That's going to give me 0 minus 3. So g of 0 is equal to negative 3. Problem 16 asks us now to evaluate x when f of x equals 32. So instead of giving you the input, I'm now giving you the output. So I know that 32 is going to be equal to my f of x, which is negative 2x plus 4. And I now need to solve for x. So I can subtract a 4 on each side. That leaves me with 28 equals negative 2x. Then divide by negative 2. So x is equal to negative 14. Number 17 is asking us to do a similar activity. So it is saying that I've given you an output now. You need to find the input for g of x is equal to 7. So I have 7 is equal to 2x minus 3. I'm going to add 3 to both sides, which gives me that 10 is equal to 2x. I'm going to then divide by 2. So x is equal to 5 for number 7. 18 and 19 are now going to combine these polynomial expressions into one singular polynomial expression. So 18 says f of x plus 2 times g of x. So I know f of x is negative 2x plus 4. We'll want to add to that 2 times g of x, which is 2x minus 3. So my first step is going to be to distribute that 2 to that second polynomial expression. So I have negative 2x plus 4 plus 4x minus 6. Because it's addition, I can now just combine like terms. Negative 2x and 4x is going to give me a positive 2x. And then 4 minus 6 is going to give me a negative 2. So therefore, f of x plus 2g of x simplifies to 2x minus 2. For 19, I've got negative 2x plus 4, which is my f of x, minus my g of x, which is 2x minus 3. For this one, I'm going to change the values for that second function. So I'm going to change this to addition, and it's going to be negative 2x plus 3. I now can combine like terms. I've got negative 2x plus negative 2x to give me a negative 4x, and positive 4 plus 3 to give me a positive 7. So f of x minus g of x gives us the expression negative 4x plus 7. All right, now we're going to go back to sequences just for a second. So I'm looking at an arithmetic sequence of 2, 6, 10, 14. And I want to identify the domain for this sequence. Your domain is just your counting number. So I'm looking at my term numbers here. So I've got a term number of 1, 2, 3, and 4. So therefore my domain is just 1, 2, 3, 4, and it could continue on. And my range is going to be my actual sequence values. So I've got 2, 6, 10, 14, and it can continue on from there. 21 kind of wraps this all up into an application with our arithmetic sequences. So this one says that Luigi is training ponies to ride surfboards. He's got 5 ponies that can ride a surfboard in month 1. In month 2, he trains 7 more. By month 3, he trains again 7 more. We want to write an explicit formula to represent any number of ponies. So I know he starts out with 5 ponies, so that's my initial value. And my common difference is that he's adding 7 more each time. So my explicit formula is going to be a sub n is equal to 5 plus n minus 1 times 7. I'm going to distribute that 7 through to the parentheses to give me a sub n equals 5 plus 7n minus 7. And combine like terms to get a sub n equals 7n minus 2. Now, using that explicit formula, I want to determine how many ponies will be able to ride surfboards by the 15th month. So that means I'm going to replace my n value with 15. So anywhere I have an n, I'm going to replace it with the number 15. So in my calculator, I can do 7 times 15 minus 2. That means that Luigi trained a total of 103 ponies by month 15. And guys, that is all of the review from Unit 2 in this packet.